Hello. So today we're going to be looking at measuring compound units, this time with the metric system. So within the metric system, as we've seen several times already, it's quite simple to convert. It's all based off of powers of 10, just like with your place values. In the center, we have our base units, meters, liters, and grams, and then we add prefixes in the front of them to tell us how we're moving. So our smaller ones are going to be milli, centi, and deci. Deci means tenth, centi means hundredth, milli means thousand. On our largest scale, we have deca, hecto, and kilo. Deca is 10, hecto is 100, kilo is 1,000. So I have a compound problem for you. I, in my car, get 600 kilometers for 45 liters. Sorry. We live in Arizona, so a lot of people actually do have their cars that do these type of conversions because they go home to a certain area to the north of the U.S. to live sometimes in a year. It's Canada. Canada still uses the metric system. So a lot of times they have to understand these conversions. So if you are one of those, that's going to be very helpful for you to understand how to convert between the two. You probably already know. But if not, here's a good tool for you. So car gets 600 kilometers for 45 liters. Okay. Well, I want to know exactly how many meters do I get per milliliter? How many meters do I get per milliliter? All right. Well, currently, we know that we get 600 kilometers per 45 liters. And we can start there, or we could even reduce that if we would like. So let's go ahead and reduce it, because remember, when you reduce it, it makes it a lot easier to convert later. So we get 600 kilometers for 45, and we end up in that case with 40 over 3. So we get 40 over 3 kilometers per liter. So we'll start with that number. So we have 40 over 3 kilometers per liter. So 40 kilometers per 3 liters. Okay. Remember, we want our final result. We want to know how many meters per milliliter of gas we get. Okay. Well, let's figure that out. So for each milliliter of gas, how many meters can we go? So to go from kilometers to meters, we'll start there. Got kilometers, meters. We know that 1 kilometer is the larger one. I usually like to do that with the large ones, as you've seen. There are 1,000 meters, or 10 to the third meters. Okay. So for the liters, going to milliliters, we know that 1 liter is going to be equal to 10 to the negative third milliliters. All right, sorry, 10 to the third milliliters, because it's a smaller value, right? So 1 liter equals 10 to the third milliliters, or 1,000. 1,000 milliliters will equal 1 liter. Okay. So I tend to write that this way for a very specific reason, especially when we get to when we're using the metric system. The reason is, as we see our units cancel, kilometers goes away, liters goes away, we're at where we want to be, meters per milliliter. We also see something very nice. And it's, as you've seen, usually happens, and I'm going to keep expressing this over and over and over again so you can understand why converting with the metric system is so easy. We have a certain number power of 10 divided by another certain number power of 10. In this case, actually, we even see 10 to the third divided by 10 to the third. Well, that would just cancel completely, and our answer will actually just be the same. We get 40 thirds meters per milliliter. Or if you want to simplify that even further, we get 13.3 repeating meters per milliliter. Of course, going by significant figures, because we have only one significant figure here, we would end up with 10. So that means we get 13.3 repeating, or 13 and a third meters for every milliliter of gas we have. That's not bad, right? Might be kind of hard for you, many of you to visualize how much that is, but all right. So that is a compound unit of measurement. Remember, compound means you take two different types of units of measurements and put them together, okay? I'm going to show you a common one that's used in science. And it is going to be kilograms times meters per second squared. Kilograms times meters per second squared. And let's say that I have 10 kilograms times meters per second squared, and I want to know how many centigrams times kilograms per hour this is. So that's a lot going on, right? We're converting kilograms to centigrams, we're converting meters to kilometers, and we're converting second squared to hour squared. A lot of conversion going on. Let's try to pack this in together. Luckily, our number starts off as 10, so that might help things out a bit. So let's see what happens. So we start off with 10. We have kilograms times meters. That means they're both going to be in a numerator. And this is all over seconds squared. Okay? Well, which one do you all want to convert first? I tend to stick with the first thing I see. We're going for kilograms to centigrams first, so I'm going to work with that. Well, kilograms to centigrams. Do you know how many centigrams are in a kilogram? No? That's okay. One easy way to do this is going from kilo down to centi. We have 1, 2, 3, 4, 5. So that would be 10 to the 5th. For just one of those. The other thing you can do is set both of them to be the meters. So we know that this is 100 meters, and we know that this is 1,000th of a meter. So you can put both of those numbers there. So two ways to do it. You can put the, not meters, grams. You can take both of these and set them equal to how many grams it would be. Or you can just count down 1, 2, 3, 4, 5. So it'll be 5 of them. So 10 to the 5th power. Okay? All right. So that's for the kilograms. And let's look at the next thing. The next thing is going to kilometers. So our answer needs kilometers. We have meters to begin with. We know that there are 10 to the 3rd meters per 1 kilometer. To get from kilometers to meters is 1, 2, 3. So 10 to the 3rd power. Okay. Now, lastly, we are going from seconds squared to hours squared. Maybe you don't know how many seconds there are in an hour off the top of your head. Maybe you do know how many seconds there are in a minute, though. So if we do this properly, let's go to minutes squared. We know that for 1 minute there are 60 seconds, but this number is squared, so it's going to be 60 squared. Then from minutes squared to hours squared, we know that for 1 hour there are 60 minutes, so 60 minutes squared again. All right, so this is a lot of numbers to deal with, right? Well, that's fine. What we can do is we can leave our 10s multiplied together, because this will be 10 times 10 5 times, so then that would be 6 of them in total. So we could leave that if we wanted, or we could just multiply it all together. Multiplying all together might be fun. But we already know that whatever we get, we multiply these two, is going to have 6 zeros behind it. And it's going to be divided by the 10 to the 3rd in the denominator. So really, 3 of those zeros will disappear. So I'm going to do the whole thing, though, just because I think that's fun and kind of cool to see a really, really huge number. So we're going to do 60 squared times 60 squared, and I get 1,296, and then I get 1, 2, 3, 4 zeros plus the 6 there. 1, 2, 3, 4, 5, 6. So I have 10 zeros following. Okay. In the denominator here, I'm going to divide by 1,000. 3 zeros following. So what I can do is get rid of this, get rid of 3 zeros. And so my answer will be a really huge number, which is fine. I get 1.296 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th power. Adds a little scientific notation to the game, just so you get practice with that and see a practical use of it. Also, if you see kilograms meters per second squared, that's also called a Newton. That's how you measure weight in the metric system. Because grams does mass, not weight. I'm not going to let that go ever. Probably. No, I won't. No one ever should. Make the argument for me to spread my knowledge.